Hello, everybody. Thank you for coming. Thank you so much. Thank you, everybody, for coming, and welcome to the State of Ruby Tooling. My name is Vinny. I'm a staff developer in the Ruby Developer Experience team at Shopify. Our team tries to take a complete look into the developer experience for Ruby, everything you might do to interact with the language. We created the Ruby LSP. We contribute to gradual typing for Ruby, and we also contribute to IRB and Ruby debug. If you want to know a little bit more about my work, you can find me at Vinicius Stock on X and GitHub. So is having options a good thing? It's tempting to think that the answer to this question is obvious, and the answer is always true. It leads to more flexibility, a sense of freedom and autonomy. But it's not so simple. This paper from the year 2000, When Choice is Demotivating, noticed something about a lot of the previous research into the psychology of making decisions. They noticed that much of the work that came before them was evaluating decisions made on a small number of options, or decisions that weren't very complex. And they wondered what would happen if you were to increase the complexity of making the decision or the number of choices involved. And would people still feel like having options was a good thing? Would it still be perceived the same? And it turns out that's not always the case. You risk inducing something they call choice overload. And that is essentially when the effort to make the decision has become so high that the person may cut corners in order to make the decision. They may consider a smaller portion of the information available to them. They may simplify their decision-making process, or try to completely eliminate the effort involved by preferring whatever's the default or making no choice whatsoever. Today, I would like to talk to you about options in the context of developer experience. And where are we in the Ruby community when it comes to DX, developer experience? I want to begin by addressing something that I think is quite common to find, especially when discussing online, which is that making tooling for Ruby is quite difficult because Ruby is a dynamic language. Of course, there is truth to that. If you don't have type annotations, then the accuracy of your static analysis may be much worse than what it could be. But I don't think that's the main challenge that we face today, and Ruby is not the only dynamic language in existence. JavaScript is also dynamic, and the answer for a more accurate static analysis is TypeScript or gradual typing. In the Ruby community, we have a similar response. We have Steep and Sorbet that can provide you with very accurate static analysis through gradual typing. So I don't think that today that is our biggest challenge. I think the main challenge we're facing today for a modern developer experience is the fragmentation in our tooling. Let's follow the story of a new developer. They're a junior developer just starting out, and they want to try out Rust and Ruby, and they want to have a complete developer experience with everything that's available for languages today. Starting out with Rust. The first thing you have to do is figure out how to install the language. In the Rust website, they recommend using the official tool RustUp to install or manage your Rust installation. If we move on to unit testing, the user doesn't have to configure anything. The test framework is built into the language, and all you have to do is start writing your tests and executing them. If we move on to formatting, then there's an official tool maintained by the Rust team called Rust Format. If we want to add linting to the project, there's an official tool maintained by the Rust team called Clippy. And if we want to integrate all of that into the editor and have rich features like completion and go to definition, then there's also an official tool maintained by the Rust team, which is called Rust Analyzer. And if we continue taking a look at several different categories, the story repeats. Rust has a very well integrated experience that requires basically no configuration. It's an out-of-the-box experience, and most of the tools are official and maintained by the Rust team. But this well-integrated experience didn't happen by accident. Rust has a dedicated developer tooling team, which was responsible for designing this cohesive experience and coordinating the efforts of multiple sub-teams so that everybody was working towards this vision of a unified experience. What we have here is very modern default tooling and guidance coming from the language about how you should set up your development environment, what the default developer experience should be, which leads to highly consolidated tooling, and then in turn leads to several benefits. You get easier integration because you only need to integrate with one tool at a time for each separate category. You minimize the number of decisions developers have to make. In fact, if you just want to use the set of default tools, you don't have to decide anything. You minimize the configuration involved, especially because the integration works out of the box. It's very uncommon that you need to configure something in order to make the tool work. You only configure things because you want to customize your environment. You get a reduced learning curve because you can focus all of your energy in learning Rust, and everything you learn can be applied to all other Rust projects. And finally, you get a very high collaboration environment because the entire community uses the same set of tools. So if you contribute something, everybody else is going to enjoy it. When our junior developer turns to Ruby, the story is going to be quite different. At the very first step, they're already faced with a decision. There's no official way to install Ruby or manage your Ruby installation, so they're going to have to evaluate a few different options. And it's not enough to choose only one option, because some of these tools install Ruby, others allow you to switch the version, and some of them do both. And many of them are not cross-platform, or they only support a few operating systems. So here they already have to make a decision and evaluate from multiple different options. If we move on to testing, then this one is one of my favorite categories because the situation is quite interesting. It's not that we lack defaults. We have two defaults. It's test unit and mini test, both included in your Ruby installation. So even though we have a default test framework, we cannot provide users with a zero configuration experience because we don't know which one of the defaults they're going to choose. If we move on to typing, and you want to adopt a gradual typing system for Ruby, then you have yet another decision you have to make. Are you going to adopt complete gradual typing systems like Sorbet or Steep, novel approaches like TypeRough? And there are also other tools that provide you with varying levels of type checking. If we move to formatting and linting, and here I'm putting both categories mixed into the same one because a few tools in the Ruby community actually do both, so there's no clear separation. Then you also have to decide between multiple different choices, and here I'm not listing several options for linting, like security linting or code quality linting that are available to you for your projects. And finally, if you want to integrate that into the editor, then you have to combine or pick from families of different language servers. You have the type checking family focused on features that require accurate static analysis. You have the general language servers that try to give you the best experience they can, regardless of whether you adopted typing or not. And you have the formatter family of language servers, which provide you with formatting. And if we continue looking at other categories, the story also repeats. If we were to consider that our junior developer wants to have a full experience, so they want at least one tool for every category, and we artificially, for the sake of the argument, limit that they can only pick one, which is not true. You can combine multiple tools from the same category. And remembering that none of these lists are exhaustive, I missed several tools that exist out there. Rust has one possible combination of how you can configure your environment, just the set of default tools. And Ruby has the conservative number of 13,000 ways in which you can configure your environment. So if you were to visualize that, Rust would be a straight line where you just pick the next default tool and that's it. And the visualization for Ruby, of course, is impossible to see because there are too many combinations. It's no wonder that it's very hard to guarantee that integrations work on every single possible combination. And this is not considering many different categories like shells, operating systems, and a bunch of others. If we consider different projects that all use different sets of tools, then you can also conclude that knowing Ruby may often not be enough to make a successful contribution. For example, if you're used to gradual typing and you try to contribute to a project that doesn't use typing, your editor experience will be worse, and you may not immediately know why that is the case. If you take the other way around, you might find yourself learning specifics about a type system in order to be able to contribute to a project. Or you may have to learn specifics about a test framework in order to be able to contribute. You have to learn knowledge that is specific to the tooling and that doesn't apply generally to all Ruby projects. What we have here is missing defaults and guidance. Ruby is not prescriptive about what your default developer experience should be. So effectively, the DX design is delegated to the community, which ends up resulting in tooling fragmentation, and then we find ourselves with basically the opposites of what the Rust community gets to enjoy. Integration is very difficult because you have to integrate with several different versions of the same tool. And if there's a breaking change, the integration breaks, and it's hard to keep up with everything. You get an excessive number of decisions that new developers have to make. Can we expect that a junior developer will know and understand the trade-offs they're making by choosing options and deciding for all of those categories? You get so much configuration in order to make the tools work. Because integration is hard, the easiest way out is to provide a bunch of configuration parameters and let the user figure out how to integrate things. You get this steeper learning curve because you need to learn information that is specific to tools and not only information that is general to all Ruby programs. And most importantly, it spreads the efforts of our community. If we take a look at another ecosystem, JavaScript, it's also highly fragmented. They have fragmentation very similar to us, even more maybe, dependency management fragmentation, runtime fragmentation, but they have an advantage over the Ruby community. Their community is much larger. If we take a look at the results of the last Stack Overflow survey, JavaScript was the #1 programming language used by respondents with over 63% of people, and Ruby was just a little over 6%. So maybe the JavaScript community has enough investment and enough people that they may be able to support all of this fragmentation and diversity of tools. But I think that we cannot afford to divide our efforts and maintain so many versions of highly complex tools. As another piece of statistic, if we take a look at the number of contributors, and this is non-unique contributors, as of the time I wrote this slide, Rust Analyzer, the language server, had 816 contributors. And if we sum up the number of Sorbet, Steep, Solargraph, Ruby LSP, and TypeProf, and again, these are 5 actively maintained language servers, and these are non-unique, so Dependabot is being counted more than once and helping us inflate our number. And even though it's inflating the number, we're far away from the number of contributors in Rust Analyzer. And to me, this is significantly more impactful to the quality of our tooling than the fact that Ruby is a dynamic language. I want to also say that there are many cases where building new tools makes sense. The point I'm trying to make here is not that we should stop making tools. You may be exploring a novel approach that nobody tried, or you may be basing your implementation on a new technology that didn't exist before. There are several scenarios where making a new tool makes perfect sense. The point I want to make is that you don't get a better experience simply by creating more tools. You have to consider the big picture of DX and how all of the tools fit together. You could be making integration more difficult, or you could be increasing the amount of configuration required for people to configure their development environments. DX is not about one specific tool in isolation, but rather about the combination of them and how a unified experience allows you to interact with the language. If we go back to the article we were discussing in the beginning, what we want to avoid is being in the last situation there of making no choice, because that would mean that evaluating which tools you want to use was so difficult. In the best case scenario, you decided to not use an entire category and have a worse developer experience. But in the absolute worst case, it means that setting up your development environment was so difficult that the person may choose to not try Ruby and try something else. We want to be where Rust is, where the default options are so good, you don't have to choose anything. You just use the default set of tools and get a fantastic developer experience. Using tools is never the developer's final goal. No developer has as the final goal to use the Ruby LSP or to use Rails or to use Sorbet. Those are stepping stones, and the final goal is to build something. So setting up your development environment should be absolutely effortless, and we should get out of the way as much as possible so that people can focus all of their energy into what it is they're trying to build. I want to shift gears a little bit here and talk about tools as project dependencies. In Ruby, it's quite common to add tooling to your gem file, to your project dependencies. Like you have a development group in the gem file, and you add a bunch of different tools across several different projects that you're maintaining. But why is this the case? What do we get out of it? If we think about it, we get version consistency within the same project. We get version consistency on CI and across different developers that are working on that same project. But we don't get much else other than that. And there still may be inconsistency of the tooling across several projects unless you're synchronizing the updates for all of your tools. We can turn to the Rust community here again and study the approach they're taking, see if we can bring any of the learnings back to us. In Rust, most tools are installed globally as a Rust-up component. So if you want to install a linter or a formatter or a language server, it becomes a part of your language installation. And that has several interesting characteristics. You get version consistency in any project because you only use the same version of the linter across all of the projects you're currently developing, for example. And for consistency across the different development machines and CI, auto updates are much simpler. You just update the global installation, and on CI, you can ensure that you're always executing on the latest version of the tools to ensure that you're getting a consistent experience. Because the tools are all installed globally, they're all already a part of the path. So launching executables is quite easy, and integrating from other processes like editors becomes easy as well. It reduces the amount of maintenance for projects. You don't have to handle dependency updates for the same tool across several different projects. It just auto-updates or just update manually once for your entire system. And even though the tools are installed globally, they can integrate with your project's dependencies in order to deliver a tailored experience based on what you're currently working on. Now, could we have the same for Ruby? Of course, Ruby and Rust are very different. You can't easily package a gems executable into a binary like you would a Rust program, but maybe there are options that we can explore. We could have some sort of default version manager that allows you to launch any gem executable using the right Ruby version for a project. Or we could make it easier for globally installed gems to hook into your projects bundle and use your dependencies from outside. In fact, this is already being explored in a plugin called Bundler Compose. I think it's definitely worth exploring further and seeing if we can have a better experience with global installations rather than making our tools dependencies. So what could the future of tooling look like for Ruby? I want to be absolutely fair and mention that Rust is the exception here. Most languages, popular languages like Ruby, Python, JavaScript, don't have default official tooling and also suffer from fragmentation in their tooling ecosystems. In fact, the only language that I found that comes close to Rust and has official tooling is Go. And there's a relationship in these lists here. Most of the languages on the left are much, much older than the languages on the right. And so it only makes sense that Rust's developer experience is much more cohesive because many of the techniques that we use today didn't exist when Ruby was created. So it just evolved organically, and we ended up with several different versions of tools and several different approaches. But Rust has the advantage that it was created when many of these techniques already existed, and so they could plan everything ahead. Basically, analogous to a city that was planned versus a city that grew organically. But there's nothing stopping us from learning from Rust's success and bringing some of those learnings back to our community. In fact, there is already a move towards consolidation, thanks to the new Ruby parser Prism, which is helping us unify all static analysis efforts within the same set of building blocks. In fact, our team wants to upstream the code indexer that we use in the Ruby LSP to Prism, so that it can serve as a building block for other static analysis tools. For example, RDoc, which also needs to index your code base to figure out how to generate the documentation for all of your declarations could be sharing the same index so that you get the same results in the language server and in RDoc, and the maintenance is reduced. We could have a formatter based on Prism. We could have a code mods engine based on Prism, allowing you to deliver modifications at scale automatically. And with all of those building blocks, we could build several other tools like deprecation frameworks that come with auto fixes for gems, a type checker based on Prism, and linters. And because all of the building blocks are shared, integrating becomes much, much easier, and we can all integrate that into an editor using a language server. It's very long term, but I definitely believe that we will eventually achieve it. And I want to leave you with a reflection. I don't think that any of the challenges that we face today for a modern developer experience are technical. We already managed to build very successful type checkers, linters, debuggers, language servers. So what's missing? Is it coordination? Is it collaboration? Or do we think that we can't self-organize and we need an official team and governance to direct our efforts towards the right direction to a unified experience? I don't know what the answer is, but I don't think any of these look like a problem that we cannot solve. Would it be possible to have a more integrated developer experience right now? I believe the answer to this question is yes, and it comes from outside of our community. It's the language server protocol. Language servers are uniquely tailored to aggregate functionality and integrate with tools without requiring configuration from the user. But today we find ourselves in a situation where we have language server fragmentation and functionality is spread around different language servers. And of course, this impacts our developer experience as well. Most editors share an extension host where all of your extensions are executed. And so if you're running multiple language servers, first you need to configure each one of them. And then when you launch your editor, each one of those language servers is likely going to do some sort of indexing process at boot and maintain a representation of your code base, of your entire workspace in memory. And those are going to be duplicate representations. And then every single operation you do in the editor is going to be duplicated for each language server, which is also going to maintain duplicate representations of the documents you are currently interacting with. It's a lot of duplicate work, increased memory usage, and potentially one language server could make the others slower if it is consuming too many resources from the extension host. I believe that if we were able to consolidate language servers at least a little bit, we could deliver a more integrated experience to Rubyists, even with the diversity of tools that we have today. And I think the Ruby LSP can help here. We have been experimenting for a while now with something we're calling Ruby LSP addons. And this is a way for other gems to deliver integrations into the editor with no need to write an editor extension, no need to write a brand new language server from scratch and have to deal with the fundamental mechanisms of text synchronization and handling different encodings, and no need to build your own static analysis tools to understand Ruby code. The idea is that your add-on, your gem, can hook into the Ruby LSP and then get access to all of these building blocks that we use for the regular language server, like static analysis tools, a code base index, a type resolver, ways to return responses back to the editor, and encoding helpers, so that doing the right thing is very easy. In this situation, we would be left with only one language server, one representation of your code base, but then all other tools could simply hook into that base language server and enhance the functionality, so that if you're using a type checker, your features become more accurate based on the response of the type checker. Your linter is automatically hooked into the language server for showing violations and providing auto formatting. Your test framework can also be handled so that we can run your tests from the editor, as we already have support for a few test frameworks to do that. And you can even add extra functionality that is based on a specific tool like Rails, which we also do. In fact, we already have a few add-ons available. The Rails add-on adds functionality related to Rails, so it allows you to do things such as jumping to the definition of callback methods. It allows showing your schema on hover and other Rails-related functionality. We have community add-ons like RSpec support so that you can run RSpec tests directly from inside an RSpec test file. And we have internal integrations we've built for Rubocop, syntax tree, Minitest, and test unit. I want to leave you with two takeaways from this talk, which I think is the two most important steps that we have to take in order to advance developer experience for Ruby. The first one is considering the big picture, considering how all of the tools integrate together and how the entire experience of interacting with the Ruby language actually happens, and not the tools in isolation. And secondly, coordinating our efforts so that tool maintainers are working together towards this unified vision for a better developer experience for all of us. Thank you very much.